Have you ever watched sunlight dance through a window or seen a rainbow after a rainy day? Light is all around us. But here's a question that's puzzled scientists for centuries. Is light a wave, like ripples on a pond, or is it a particle, like tiny grains of sand? Today, we're diving into this cosmic mystery to uncover what light really is. Get ready for a journey through science, with experiments and ideas that'll spark your curiosity.
Let's start with the idea that light is a wave. Imagine dropping a pebble into a calm lake, like Fuel Lake. Ripples spread out in all directions, right? That's how waves work. They carry energy through space. Scientists like Christian Huygens in the 1600s thought light behaves like this, traveling as waves of energy. These are called electromagnetic waves, which wiggle through space carrying light's energy. Think of light waves as invisible threads vibrating super fast, bringing us everything from sunlight to the glow of your phone screen. Waves have cool properties. They can bend around corners, like water waves curving around a rock, and they can overlap, creating patterns. This idea explains why light spreads out when it passes through a narrow gap, or why a rainbow forms when light bends through raindrops. Pretty neat, right?
But wait, some scientists, like Isaac Newton, had a different idea. They thought light is made of tiny particles like grains of rice zooming through space. Fast forward to the 1900s, when Albert Einstein called these particles photons, tiny packets of light energy. Picture photons as little fireflies, each carrying a spark of light. This particle idea explains things waves can't. For example, when light hits a solar panel in a Nepali village, it knocks electrons loose to generate electricity. Only tiny, precise packets of energy, photons, can do that, not a spread-out wave. Photons also explain why lasers are so sharp and focused, like arrows hitting a target. So, is light a particle? Let's see what experiments tell us. So, wave or particle? Let's look at some experiments that shook up science. First, the double slit experiment. Imagine shining a flashlight through two tiny slits onto a wall. If light is a wave, it should create a pattern of bright and dark bands, like ripples overlapping in a pond. And guess what? When scientists tried this, they saw exactly that, an interference pattern. This screamed, light is a wave. But here's where it gets wild. When they fired light one photon at a time through the slits, expecting just two spots like particles would make, they still got a wave-like pattern over time. It's like each photon knew about both slits. This showed light acts like both a wave and a particle. Another clue came from the photoelectric effect. When light hits certain metals, it kicks out electrons, but only if the light's energy is just right, like a key fitting a lock. This only makes sense if light comes in packets, photons. These experiments led to a big idea, wave-particle duality. Light isn't just a wave or a particle, it's both, depending on how you look at it. So what is light? It's not just a wave or a particle, it's both. And that's what makes it so fascinating. This idea, called wave-particle duality, shows us that the universe is full of surprises. Light powers our world, from the sun lighting up the Annapurna Mountains to the screens we use every day. Next time you see a rainbow or turn on a light, think about this. Light is a cosmic puzzle that scientists are still exploring. What do you think light will reveal next? Keep asking questions, and let's keep shining bright. Thanks for watching. If you found this helpful, please give it a thumbs up.